the part I wanted to take. But basics, you should.
Madam, your voice is very low. Please. Low.
Yeah. Hello. Sir, am I audible?
Yes, yes, madam. Please.
Hello. Okay. So this is the part I want to take, ma. 2-point test cross. Here you will be actually, now we have entered into the gene mapping concept. Okay. We have entered into the concept of gene mapping. Means here we are trying to know the distance between two genes. This is very interesting. Okay. We are trying to know the distance between two genes. Okay. So first we'll be dealing with 2-point test cross. This is there in the syllabus. So it is compulsorily you will be getting the questions from this area, right? So to know the distance between two genes. So we have taken two genes, capital A and capital B, and its alleles are small a and small b. Here you see the this part. Okay, I have drawn two genes somewhat closer in this. So little distance is increased here, more distance is increased. So we are taking different conditions where the genes are present at different distances. And here this 2-point test cross we are doing to know the distance between two genes, and the distance always is measured in centimorgans or Mach units. This also you can get important question. What is the units? What are the units in which the distance between the genes is measured? That is always centimorgans or Mach units. It can be anything, centimorgans or Mach units. Okay. Now, to determine the recombinant frequency between two linked genes. These are two genes present on the same chromosome. Okay. As I told you, all the genes present on the same chromosome is called as linkage group. We consider them as linked. Okay. So these two genes we have taken two linked genes. In Mendelian dihybrid test cross ratio, Mendelian dihybrid test cross ratio. Here you have to understand dihybrid means two characters we are considering, test cross. So what is the dihybrid F1 genotype? Ma? If we take RR, R and W as the gene, what will be the hybrid genotype? Capital R, smaller, round and wrinkled, and one second. Yellow and green. You are considering two characters, round and wrinkled, yellow and green. Okay. So always hybrid will have heterozygous nature, capital R smaller and capital Y small y. That will be the genotype of the F1 offspring or F1 hybrid. Okay. So that hybrid will be crossed with recessive parent. That is smaller, smaller, small y, small y. Okay. In the coming pages, I'll show you. So that time they got the ratio 1:1:1:1. This is the ratio got by Mendel. Okay. Any deviation from this ratio, will be due to linkage. Any deviation from this ratio will be due to linkage. Okay. So these are the ratios. Phenotypic ratio of dihybrid cross is 9:3:1. Just note down. And this is the genotypic ratio. In the last class, I forgot to share. This is genotypic ratio of dihybrid cross, that is 1:2:1:2:4:2:1:2:1. This is the genotypic ratio. This can be asked. This also you have to remember. Phenotypic ratio also you have to remember. Okay. Test cross ratio. Test cross means always it is the cross between hybrid, that progeny and the recessive parent. Progeny and the recessive parent, that is test cross ratio. Or if you are making a cross between the progeny and any of the parent, that is called as back cross. If you are making a cross between progeny and the recessive parent, that is a test cross. Am I clear? ikkadi varaku ardhamaindamma pillalu? Yes, girls, any doubt? Anywhere? You can ask. Yes, ma'am? Shall I move on? Okay.
Yes, ma'am.
So there are different possibilities. We are talking about two genes A and B. If they are very close to each other, there cannot be any recombination. There cannot be any crossing over. So there cannot be any recombination. So 0% recombination means 100% parental. Understood? If two genes are present close together, there cannot be any recombination. So zero recombination percentage is 0 and parental percentage will be 100. These two are reciprocal with each other. And if A and B are intermediate distance, if there is intermediate distance, there is a possibility of recombination. What is the percentage of recombination here? 0 to 50%. It can be anything from 0 to 50%. So parental combination will be 50 to 100%. And A and B are very far. If they are very far, then 50% recombinants will be there, 50% parental will be there. Here you have to remember one point, maximum percentage of recombinants is 50%. What is the maximum percentage of recombinants? 50%. Okay, if they are very close, 0%. If they are intermediate distance, 0 to 50%. If they are very far, then the maximum percentage is 50% recombination. Is this clear?
Yes, ma'am.
Next point. Here we got one problem. Like these questions will be asked. See, this type of questions, if you are preparing here, it can, like, you can get these questions in CU set, not only in CU set, even in net also, net level also, this concept will be the same. Okay. So this is the problem you have given. Okay. And this is a cross between two genes, round and yellow, wrinkled and green. These are the two characters. Okay, this is the genotype. We are talking about dihybrid test cross. We are talking about dihybrid test cross. See, you leave this. You don't consider this. You consider only this. Capital R, small r, capital Y, small y. This is the hybrid or progeny of cross between two parents. Okay, capital R, small r, capital Y, small y. Into recessive parent. It is crossed with the recessive parent. So what is the type of cross here? We are crossing a hybrid with the recessive parent. What is the type of cross here, ma?
Dihybrid cross.
Dihybrid. One more word should be there. We are crossing the progeny or
Test cross.
recessive parent. Yes, very nice. Dihybrid test cross. We are crossing when we are making a cross between the F1 hybrid and the recessive parent, it is a test cross. And when we are making a cross between the F1 hybrid and any of the parent, it is back cross. Am I clear? If any of the parent is involved in this cross, then it is called as back cross. If we are taking only recessive parent, then it is called as test cross. You should be clear with these concepts. Okay. Now we got the they have given the combination. They have given the combinations. What combinations? Number of progeny they have given. Okay. So this is the genotype. Capital R, capital R, capital Y, capital Y, capital R, small r, capital Y, small y. So what will be the phenotype of this genotype, ma? First. What will be the genotype? Oh, sorry, phenotype. Capital R, small r, or capital R, small, oh, sorry, capital R, capital R, small r. Phenotype will be round. Yes or no? Round. Capital Y, small y, or capital Y, capital Y? Fast.
Yellow.
Very nice. So phenotype of the parent is yellow. Clear? Smaller, smaller. Round ki recessive character.
Wrinkled.
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 Wrinkled. Small y.
Green.
Yellow ki recessive character.
Green.
So wrinkled and green. Okay, these are the parental combinations. Okay. In the last slide also I told you always the parental combinations will have high number of offsprings. ఈ కాంబినేషన్స్ ఎక్కువ ఉంటాయి. ఏదైతే రిజల్ట్ వస్తుందో మనకి క్రాస్ తర్వాత అందులో నంబర్ ఆఫ్ ఆఫ్స్ప్రింగ్స్ హ్యావింగ్ మోర్ నంబర్ విల్ బి జనరల్లీ ఆఫ్ పేరెంటల్ టైప్. అంతే కదా, ఎక్కువ నెంబర్ ఉంటే ఏ టైప్ అమ్మా? పేరెంటల్ టైప్. తక్కువ నెంబర్ ఉన్నవి రికాంబినెంట్స్. ఓకే, Now you see capital R, small y, small y. What will be the phenotype? Round
Round.
and
Green.
Green, ma'am.
Yellow.
round and green. Green. So RG, this is a new character. Okay. Here, wrinkled
Yellow.
and yellow. And yellow. So this is a new character. So these are recombinants. మనకి పేరెంట్స్ లో ఇవి లేవు. పేరెంట్స్ ఎట్లా ఉన్నారు? రౌండ్ ఎల్లో లేదా wrinkled green ఉన్నారు. కానీ ఇక్కడ ఇవేంటి? రౌండ్ గ్రీన్, wrinkled yellow. These are recombinants. Understood? Parental combinations will have high number. Recombinant combination will have low number. So this is the number of offsprings. So what they will ask is, ఇట్లా numbers ఇచ్చి వాళ్ళు అడుగుతారు, calculate the recombination frequency between these two genes. What they are asking? They are asking the calculate recombination frequency between these two genes. Okay, and these are the numbers. So how you calculate recombination percentage is, these are the recombinants according to you. అవునా కదా? recombinants ఏవమ్మా? ఈ రెండు. So take these values, 148 plus 152 by, what are the total numbers? 345 plus 355 plus 148 plus 152. You calculate this. Write down the numbers and calculate. 148 plus 152 by total. You'll be getting around 30%. Okay. So what does it mean, ma? We got 30 here. So what does it mean? There is a 30%
Intermediate
recombination.
distance.
Yeah, intermediate distance, very nice. And we can say that here, there is one more point you have to remember, one more concept. 1% recombination frequency is equal to 1 centimorgan. 1% recombination frequency is equal to 1 centimorgan. Here you are saying 30% recombination frequency. So the distance between two genes will be how many centimorgan? First, how many
30
centimorgans? 30 centimorgans. Very nice. Very nice. Okay. 1 unit, 1 centimorgan can also be called as one map unit. Map unit, 1 unit of map distance, or map unit or centimorgan, it is the same. So if there is 1 unit map distance or 1 centimorgan distance, it means there is 1% crossing over. Okay. So this was about 2-point test cross. Clear? In the next class, we'll be dealing about 3-point test cross. Is this clear till here, ma? Ardhamainda andarki? Yes, girls. This will be uploaded to YouTube at Tirupati sir. He will be giving the video also. You can again listen to the class. You will definitely understand this 2-point test cross. 2-point test cross means we are just trying to know the distance between two genes. Here we have taken capital A and capital B, right? And then we got the numbers, right? We got the number of offsprings. Number of offsprings will be more in parental combinations and less in recombinant combinations. If we are asked to calculate the recombination frequency between two genes, then what we have to do? Percentage recombinants formula is, you have to add the number of offsprings of recombinant varieties by total number of parental combinations, or total number of combinations. Then you will get the distance in, or recombination frequency you will get. Okay. Whatever the recombination frequency is, that many centimorgan units is the distance between two genes. Clear?
Yes, ma'am.
Okay. Similarly, this only point I am showing you, but it will take more time to show this 3-point test cross. 3-point test cross means at 3 points, 3 genes we are taking. Okay. There is a possibility of no crossing over, single crossing over, and double crossing over. What are the possibilities? There is no crossing over. Okay. Then combination will be capital A, B, C, small a, B, C. If there is single crossing over between A and B, if there is crossing over here. So what happens, ma? Capital A, then it will cross like this, na? Small b, small c. Capital A, small b, small c. At this point, there is a crossing over. Now, another chromatid, small a, capital B, small c. Okay, this is the combination. Here, single crossing over between B and C. If this here crossing over is occurring, so what happens? Capital A, capital B, small c, small a, small b, capital C. Okay, this is the product. If there is a double crossing over, first there is a crossing over here. So capital A, small b, small c will be there. Another crossing over occur here. Okay, we are talking about double crossovers. One crossing over at this place and another crossing over at this place. First ikkada indi crossing over, tarvata ikkada indi. Okay, so what happens? Capital A as it is untundi, small b it will be there. Again there is a crossing over at this point. So what happens? Again there will be exchange. So after small b it will come to capital C. Capital A, small b, capital C. Ikkada ardhamainda meeku? All of you?
Yes, ma'am.
Sure? All of you are able to understand? Capital A, small b. Ikkada malli crossing over ayindi kabatti again you have to come back. Capital C. Malli atlage small a, capital B, small c. Okay. So these are the combinations. So how many combinations we get with different types of crosses? Okay. If it is a 2-point test cross, you have to write 2 to the power of 2. How many combinations you will get? 4 combinations. If it is a 3-point test cross, 2 to the power of 3, you will get 8 combinations. What do you mean by this power, ma? 2 power 3 means 2 into 2 into 2. 2 to the power of 2 means antena? What is
Yes,
the
ma'am.
least number?
5 and 4.
Means here double crossover. What is the majority number? This 349 and 360. Means these are parent combinations. Here there is a double crossover. Definitely these two middle numbers, they are showing single crossover. They are showing single crossover. So this is the genotype. They will give this also. Capital A, small b, small c, small a, small b, small c. Sorry, small a, capital B, capital C. So here, where is the crossing over occurred, ma? Between A and B genes. Yes or no? Manam rasam kada intaku mundu. Single crossover between ikkada. Crossing over between A and B. What is the product? Capital A, small b, small c. Small a, capital B, capital C. So same thing they are showing here. Capital A, small b, small c, small a, capital B, capital C. These are the recombinants for crossing over between A and B. Now these are the recombinants for crossing over between B and C. Capital B, small c, small b, capital C. Okay. So if we are asked about calculate the percentage recombination between A and B. So what are the recombinants here? Between A and B? 114 plus 116. Yes or no? Ekkada indi crossing A and B madhyalo? Ikkada indi. Okay. Apart from this, there is also crossing over in double crossover. Double crossing over lo kuda ayindi kada? Yes, ma'am.
Yes, ma'am.
Yes. So you have to take 114 plus 116 plus 5 plus 4 by total number of values. You will get the percentage recombination between A and B. Is this clear?
Yes, ma'am.
అర్థమైందా? A and B మధ్యలో క్రాసింగ్ ఓవర్ ఉంటే మీకు రికాంబినేషన్ ఫ్రీక్వెన్సీ ఎంత? 114 ప్లస్ 116. ఈ డబుల్ క్రాస్ ఓవర్ ఎందుకు కన్సిడర్ చేయాలి అంటే 2 పాయింట్స్ లో మీకు క్రాసింగ్ ఓవర్ అయింది కాబట్టి యూ హ్యావ్ టు కన్సిడర్ దిస్ ఆల్సో. Okay, you are taking 4 values divided by all the entire values. You will be getting the recombination frequency between capital A and capital B. Similarly, you can calculate between B and C. Similarly, you can calculate between double crossover also. If this is clear, we'll wind up the class. Right? Shall we stop?
Yes, ma'am.
Okay. Sir, we'll stop the
Madam.
class. I have
Madam,
one.
thank you. Madam, thank you.
Yeah. Okay, sir. Thank you.